If you ever wonder how aviation air defenders protect pilots and ground crew from the deafening roar of jet engines while keeping the communication crystal clear, let's uncover the science behind this life-saving device.
Hello everyone, I'm Firdaus.
I'm Leon.
I'm Johnson.
We are a group of 3.3 and welcome to our Mechatronic mini project.
Our topic for the project is to research the high technology that used in the aviation industry that improve the quality of life, happiness and well-being.
In today's video, we will show you the essential functions and the electrical components with attached of the electric circuit diagram about the aviation air defenders. From non-reductions to communications enhancements, we will explore and show to you how the device are to be engineered and perform in such an extreme environment.
Hello everyone. Now I will discuss the importance of ear defenders for aerospace ground crews. These workers face constant exposure to hazardous noise, and ear defenders play a vital role in protecting their health and ensuring operational efficiency. Let's explore their benefits, current innovation, and future potential. Ground crews are regularly exposed to noise from jet engines and heavy machinery, which can cause hearing damage, fatigue, and reduce performance. This makes effective hearing protection essential for their safety and productivity. Benefits of ear defenders. Modern ear defenders can reduce noise by up to 40 decibels, preventing hearing loss and improving focus. Features like active noise cancellation and built-in communication system ensure clear communication in high noise environments. Additionally, they reduce stress and fatigue, enhancing both mental and physical health while ensuring compliance with safety regulations like OSH and ICAO standards. Recent advancements include active noise reduction (ANR), which cancels low-frequency noise, as seen in Bose and 3M products. Also, there is smart communication system like those in David Clark series, integrated Bluetooth and noise filtering microphone for seamless communication. Devices like Honeywell Scenes offer modular, ergonomic design for comfort, while Sensor integrated noise dosimetry sensor to monitor real-time noise exposure. Emerging technologies include adaptive noise cancelling, which dynamically adjusts to environmental noise, and AI-enhanced filtering, allowing essential sound to pass through. Innovations like piezoelectric energy harvesting could power devices using ambient vibration, while bone conduction technology enables clear communication without exposing ears to harmful noise. The future potential. The future of the ear defenders include augmented reality for displaying real-time safety alerts and task updates. IoT connectivity and built-in health sensors could monitor fatigue and improve efficiency. With advancing algorithm, hearing protection will continue to improve in complex noise environments. In summary, ear defenders protect ground crews from harmful noise while enhancing productivity. Current innovations and future advancements promise even better protection and functionality. Investing in these technologies ensures worker safety and sets new industry benchmark. That's all. Thank you.
For my part, is going to present a schematic circuit diagram that was built and for the product of aviation ear defenders. So we look at the whole circuit. This is all the circuit, and we will show you how this works from on the input and the output. And for the input sections, from left channel, this is left channel and right channels. We have the R1, R2, and R3 in the circuit in the left-hand side part. Okay, for this three circuit, it is the resistor to form a voltage divider and help control the input signal levels. In the left-hand side, we also have the C1 and C2. C1 and C2, both of the capacitor is a coupling capacitor that will block the direct currents components from these input signals. And in the left-hand side part, we have the RP1. RP1 is a potentiometer that allows the manual adjustment of the signal levels. Then we look at the second part is the operational amplifier, which is in the square box. It's the middle part is the operational amplifier that will amplify the input signals. And we have the R4 and R5 just below the amplifiers. This is the feedback resistor. They will set against of the amplifiers and send it to the amplifiers. For the capacitor 5 is just below the amplifiers. The C5 is act as a bypass capacitors. They will to stabilize the power supply. Then we look at the third part is the noise filtering and signal conditioning, and how was the noise being reduced, and noise reduction happens for whole the circuits for the aviation ear defenders. So first of all, in the C3, just beside in the right hand side of the amplifier, we have the C3 and the C4. These both capacitors is the filter capacitors that will smooth out any high frequencies noise or fluctuations in the circuit. Beside the amplifier, we have the D1 and D2. This D1 and D2 is the diodes that will provide protections against voltage from spikes or reverse polarities. Okay, the fourth part is the transistor stage, which is the Q1, Q2, and Q3 in the this is shown at here. And the N is we use the NPN bipolar junctions transistor that will amplify the signals further for driving the lot. So for example, it's the headphones or the speakers. And for the R8, R9, and R10 to 11 up to 11 is the biasing resistor for the transistor. Just beside the circuit is just assembled beside the transistor is to set their operating points. And we have the capacitor in C6. Capacitor in C6 is the coupling capacitor to pass the amplified signal to the output. Okay, so for whole the design at here to be shown in the presentations, we do have a power supply which is use the battery source, and this battery source is actually the direct current that will provide the necessary powers and to operate the operational amplifiers inside the circuit and the transistors. So we have the output. Okay, so just on from left hand side is input sections. Input section is the wave that will go inside the microphones that we receive in the earphones. This is the left hand side. We have the right hand side is the output sections, which is we have the R12 and R13. R12 and R13 is the resistor that will set the output impedance and protect the transistors. For the design at here, we use the theory of the stereo noise reduction circuit that we use the low power operational amplifiers. Here is the SAM in the middle one here. This amplifier is actually the same one. Then the package type, this is in the professional ways, it's MCP6001U. This is the package types. All in all, the circuit is worked simply, just in a summary. So the input signals, which are sound wave from the external environments, are received through the left and right channels. Then the coupling capacitor will eliminate any direct current offset from these incoming signals. The operational amplifier will process the signals, while the feedback resistor controlling the gain. The capacitors filter the signals to remove the high frequency noise. The amplified signals are then passed to the transistor stage of Q1, Q2, and Q3, okay, which will provide additional amplifications to drive the speaker inside the ear defenders. Then finally, the amplified signals are delivered to the left and right output channels. The circuit will always ensure a clean amplified audio signals that is suitable for aviation or audio applications is produced and sent to the users. So this is how the signals and how the circuit works in our projects.
We're going to talk about the functionalities of the components in our project. First, we are using an input resistors, which is having a functions of controlling the flow of electric current, set voltage levels, and also limit excessive current in a circuit. The way it's important is because it helps us in adjusting and stabilizing the signals level in the amplification and noise reduction circuit. Next, we are using a capacitor, which is having functions of storing and releasing electrical energies, filters signals in a way of smoothing out high frequency noise or fluctuation, and also it will block direct current while allowing alternating current to pass. It is important because it will help us to smooth out the power supply fluctuation to ensure the operation is always stable. We are also using inductors, which stores energy in a magnetic field while current flows through them and also resists changes in current. It's important it is used in conjunction with capacitors to create filters that isolate or modify specific frequency bands. Besides, we are also using diodes, which converts AC into DC by undergoing rectification. It's important because it ensures the circuit is not damaged by accidental reverse polarity or voltage surges, and it will provide protection against voltage spike and also reverse polarity. Other than that, we are also using a microphone, which is at the external part of our ear defender. It picks up external environment sound and converts the sound wave into electrical signals for processing. It will provide the system with the external noise data needed to generate the anti-noise signal. We are also using a speaker in it. The function is to convert the electrical signals back into sound wave, which will then be transferred back to the user. It's important that because it will help us to produce the anti-noise signal in real time, which will effectively cancelling the unwanted sound wave. We're using an operational amplifier, which helps us to amplify the input signals. It enables the circuit to generate an anti-noise signal that effectively cancels out external noise through disruptive interference. For the output resistors we are using, the functions is almost the same with the input resistors, which is controlling the flow of electric current, set voltage levels, and also limit excessive current in the circuit. It's important because it can set the output impedance and also protect the transistors. Thanks for watching.